So this video is looking at the equations for P4. Now there aren't that many mathematical equations in P4, but there are a couple of other equations I want to think about very briefly. So the only real mathematical equation in P4 is the equation for resistance, which is Ohm's law, which is resistance. The unit of resistance is the ohm, which has got a funny symbol, which is omega, but we call that the ohm, and voltage measured in volts divided by current measured in amperes. Now, because this is linked to electricity, they can include a couple of other equations linked to this, so they can include the equation for electrical power and general power that was in P2, that could come back again. But mainly it's this equation for resistance. They do expect you to understand some proportionalities about resistance. So resistance is directly proportional to length. So what that means is the longer a wire is, the bigger the resistance. It's also directly proportional to temperature. So the hotter the wire, the greater the resistance, because there are going to be more electron-ion collisions. And the last proportionality is the resistance is inversely proportional to area. So if I've got a thin wire compared to a thick wire, the thick wire will have a lower resistance because there is more area for the current to basically spread out, and therefore you're less likely to get electron-ion collisions. Think of it as like trying to force water down a very small pipe. It's a lot harder, there'll be much higher pressure because there isn't as much space. So as area increases, resistance decreases. That's what we mean by inversely proportional. Mathematically, that's it for P4. However, P4 contains the topic of radioactivity, and in radioactivity there are a couple of other equations we need to be aware of, and these are called nuclear equations. So first of all, it's important to understand notation on the periodic table. On the periodic table we have a symbol for an element and we have two numbers. Now in terms of nuclear notation, we give these letters, one's Z and one is A. So to give you an example you can relate to, if I've got carbon on the periodic table, it would normally, on a standard periodic table, look like that. So we have the symbol, which is C, and we have the atomic number, or the mass, the atomic number, or the proton number at the bottom. That tells us how many protons there are, which in an atom is the same as the number of electrons as well. And then at the top we have the mass number. Remember, the mass number is protons plus neutrons. So it's important to remember that first of all. So when we talk about nuclear equations, we're basically going to focus on two processes. We're going to focus on alpha decay and beta decay. Now alpha, remember, is a helium nucleus. That's what an alpha particle is. And so what happens in alpha decay is the nucleus is unstable and it ejects an alpha particle. So for example, if I've got uranium, which is 92.238, what we're going to use, what will happen when that undergoes an alpha decay is the number at the top will decrease by 4, so it will become 234, and the number at the bottom will be decreased by 2, so it'll become 90, and that's will change the element. Because the proton number has changed, that gives you a new element, so now it will become a thorium. You won't be expected to remember which element it will turn into. What will happen in your exam is you'll be given an equation with symbols, and then you will have to just fill in the numbers. So actually it's very simple to do, because all you've got to do is make sure the numbers on the left add up to the numbers on the right. So we have 238 going to 234, and then we'll have 4 in the helium, and then 92 going to 90, because the 2 again is in the helium. So that's an alpha decay. So the general equation for alpha decay, if I just use these symbols then in terms of remembering what to do, is when you have an alpha decay, the mass number at the top will always decrease by 4, and the atomic number or proton number will decrease by 2. You'll have a new element, and then you will have your helium nucleus, which is your alpha particle. Now beta is slightly different, because in a beta decay a neutron will turn into a proton and an electron, and In terms of nuclear notation, we often write protons, neutrons, electrons like that. Don't worry too much about the numbers. And I'm just going to add that we also get another particle called an anti-electron neutrino. Now, do not worry if you're not expected to remember that, but we do get an extra particle there. The main bit you need to know is that a beta particle is a high-energy electron, and that's what we release here. But in order to do that, a neutron must turn into a proton. So, in terms of, if I use carbon 14 as an isotope of carbon 12 as an example of this, what will happen is if a neutron turns into a proton, the number at the top, which is protons plus neutrons, will not change. It will still be the same because all I've done is turned one neutron into a proton. So that will still be 14. But the number at the bottom, which is, remember, the atomic number or proton number, if I've gained an extra proton, will go up by 1, so that becomes 7. And so again, I will have changed my element, that will become nitrogen, and I will get my high energy electron, which I can also write like this, or I could write as a beta particle, like so. So the general equation for beta would be that you've got your atomic mass number and your atomic or proton number. The mass number always stays the same. The atomic number, you add 1, you'll get a new element, and you'll get your beta particle, which you can write in either way, like so. So just as it's not a mathematical equation, but nuclear equations are important in P4, so you need to be able to do them. The main thing to remember is that the numbers are along the top, and the numbers must add up on the left and the right side. So you should be able to see that nice and clearly. You won't, like I said, be expected to know what element is going to be formed, but you are expected to be able to fill in the numbers.